Hello and welcome in the third video of this series where we are working together to create a Pomodoro timer with React. In the previous video we created all the display components that are dumb in some way by just receiving props from their parents and showing information. We created buttons and display of the timer, but it didn't do anything. If we click on the button, we just have console log, but nothing more. In this video, we are handling the logic of our components. As I explained in the second video, we have a distinction between the dumb component that just are receiving props and showing them, and smart components, or also containers, that are handling the logic of our application. In our code, we have a container that we have called Pomodoro. The Pomodoro will be responsible for this logic. But how can we handle logic, state, and stuff in React? You know, there's two possibilities to write React components, with classes and with function. The classes is kind of like deprecated. It still exists, it's still usable, but React, the evolution of React is to handle component as functions. And so for handling all the dynamic part of our code, the state stuff, we are using stuff that are called hooks. The hooks are utilities function that can handle dynamically some states, some variables that can change during the lifetime of our application. Here, for instance, we have the running variable. It's just a variable to say, okay, here's the state of the timer, is it running or not? Currently, it's just static value, a false, but it can be true. If we want to handle that dynamically, we can use the useState hook. So we can just import useState from React and say, okay, here, how it will be working. The useState hook is really simple to handle. We can call useState and giving a default value, which will be false. And the useState hook will return a table with two variables in it. The first one will be the state, so the running value that will be true or false. And the second one is a setter. By convention, we are calling it set, following by the same name of the state. So now we have two things. We have a running variable that will always reflect the true value of running, and we have the setter, set running, that will be called when we want to change the value of running. So here we can just say, okay, so we have running, it's passed to the tools, and now we just want to change it. And for that we have the play pause button. So here, instead of saying play pause in the console, we will just say set running, the invert, the opposites of running. And now we can see we have changed the value. Okay, that's how it works for the use state. It's really easy and there's not so much to do. We will not keep that way because it's not the place I wanted, but just for the sake of it, I will commit that, so we keep a track. But we have more to do than just running. We need to handle the timer of our application. For that, we will create a custom hook, a hook that will handle a timer for us. This timer, this hook, will just return the running state and the remaining seconds. And it will also allow us to modify this running state and modify the seconds in the timer. We also need to handle an interval between in the hook, and for that we could code our own set interval hook, but for simplicity we will use one coming from npm. It's not that I don't want to create my own interval hook and interval logic, but most of the time, and that's the way to use Node.js and npm, is that we have a lot of small utilities existing for a long time on npm that are tested, used by a lot of people, and handled carefully by the community. So most of the time it's not useful to reinvent the wheel. If you want more details about how this use interval hook has been coded, I strongly recommend you to read the blog from Dan Abramovs, which is the creator of Redux, one of the creators of Redux, and now is working at Facebook on React, about explaining how to code and handle an interval in React within a hook. It's a really interesting post, and the code that he's explaining here is the code of the use interval package that we are gonna use. So we will create our first custom hook, and for that we will create a hook folder inside the core one. And inside it we will create use timer. Oops. A hook is simply a function. It's simple as that. So we will just export a use timer function, and this function will receive three parameters, three arguments. The first one will be the initial seconds count. The second one will be the initial running, to say, okay, when I instantiate this hook, I want the timer to run. By default, it will be false. And the last one, that we will not use on the beginning, but will be a small unfinished callback. That will be called when the timer reaches end. So the parent of use timer, the container or component that is using it, will be able to interact with the fact that the timer has stopped. By default, I just want it to be an empty function, so I don't have to make verification and so on. So I will just create a small no-op function that will just be empty. That will cause us a small problem, because ESLint don't allow us to have empty functions. It's a false positive in that case. We know that we know what we do, and we know that we need an empty function just for this case. So for this time only, we will disable ESLint on the next line, but only for the empty function rule. Okay, so inside our hook, we will use a use state hooks, because we have two variables to handle here, the running one and the seconds one. That's our two variables that are gonna change, and we need to handle it. So we will import the use state from React, use state, and we will just create a running state here, which will receive the initial running value, and we will also create a seconds and set seconds that will receive the initial seconds value. And we want our hooks to return a table with the two values of the states, so running and seconds, and the two updater, set runnings and set seconds. And now we have our first custom hook. It didn't do anything right now, but we are going to use it already. So we will import here, import use timer from we will not use state anymore, and we will just say here runnings and second from use timer. The initial second will still be 1500, false for the default running, and we will not use the unfinished callback right now. We also need to import back the set running, because we know that we want to change that, set running, and we will also use the set seconds. Now we know we have the seconds, and we want to interact with that. So we'll say simply the handle minus will just now call set seconds. We could use seconds and make minus 60. But to be honest, sometimes, and I will explain why later, but sometimes it's useful in a use state case to not be bound on the value. Just saying, okay, I want to be sure to use the current value to change it. So when I call the updater, the setter, I can just give him a function that will receive the current value and will return the new one. So here we are going to do val minus 60. We will do the same with handle plus. That will be here. Oops, sorry. And that will simply be val and val plus 60. Okay. We can already test that, but we can also handle the console, the reset here. And for the reset, we will just create our constant for the default duration of a session. So we will call it session duration, and it will be 1500 seconds, which is 25 minutes, just nothing here. Okay, so we can import this value here. And we will use it here in the use timer. Okay, so now in the reset, we can just say set seconds to session duration. And we can already test that. And we have a small hiccup from parcel that happens, so just restarting parcel. Oh yeah, we created a small, oh yeah, up, sorry. Up. There is a syntax issue. We will fix that right now. Okay. So now we can test and say, I can remove minutes, I can add minutes, and I can reset to 25. One small thing that we didn't do is to handle the fact that we can go in negative, which is not a good thing. We don't have the power to change the time and space continuum, so we can't really have a negative timer. So we will just add a small verification here. We just need to say, okay, if by removing 60 seconds to our value, we can't go under 0. For that, we will use a mat.max method. Matmax is simply returning the biggest of the number we gave to him. So it will be val min 60 and 0. While val minus 60 is bigger than 0, he will use that. But when it starts to be less than 0, he will use 0. So that's a good way to control that. We will not add same mechanism for the handle plus, because if you want to have a timer of 1000 minutes is not my concern. So we can just test it if you want. And we can go back, we can go under 0. So that's a good thing. We implemented all our mechanism here. So now the last thing to do is to handle the timer inside our use timer hook. So as I said, we will use the use interval hook here. So we will simply download it, install use interval. The advantage of using that, as I said, is that it's been tested, battle tested, and we know that everything will be stable by using it. We don't create our own bugs, we are relying on them. A good thing if you want to use a module is always look at how many downloads it has, and maybe looking at the issues and stuff. The date of last published sometimes that can be important, but yeah, use that to choose packages and modules that are really stable and tested. So now we can import the use interval from use interval. As we see in the documentation, here is the default import, so we will use it. And now we can implement it, and it will be very easy. We'll just say use interval, we will give him a function that will be executed every seconds. In this function, we will just have a verification of if we are running, if the variable running is true, we will just say set seconds to seconds minus 1. We can do the same by saying val minus 1, and we will also use our matmax method just to be sure that the seconds will never go under 0. Since this can be a one-liner, we will delete the stuff, and we have everything. So our interval will simply do every second. If we are running, we will remove 1 from the count of seconds. And then the last thing is to handle the fact that the seconds reach 0. When the second reach 0, we have two things to do. We need to stop the timer by just saying, okay, running is false. And we need to call the unfinished callback. That will be send the event to the parent, so the parent can't just handle the fact that the timer is done. And for that, we need to observe the seconds count. And for that, we will use another hook. A hook that is packed with React and is called the use effect hook. Use effect is a very useful hook that is really easy to use. It will receive two arguments. The first one is a function, and the second one is a table of dependencies. Those dependencies will affect when we will run the function we gave. So every time one of the dependencies is updated, the function will be run. Here we didn't give dependencies, so the function will be run only one time when the hook is created or when the component is created. But here we want to observe the seconds. So every time seconds will change, this function will run. And in this function we will check if seconds equal 0. We will just say set running equal false, set running false to set the function, and we will call unfinished. And that's all. Now we have the whole mechanism we need to handle a small timer within React. We can just, just a styling stuff here. So that's okay. I have a small issue of configuration between my editor and the basics ESLint, so don't really mind these alerts. So our timer is completely okay now. We will just test it. For the testing, we will not use 25 minutes because it will be a bit too long. So we will just change the value to like 3 seconds. So now we have a timer of 3 seconds. We will just start. We have an issue here. Let's see. Oh, yeah, I just returned badly my my function here. Okay. Okay, so now 2, 1, up, and now the count reaches 0, so running state changes, and we are back to the default one, and we can interact with it and so on. We can still run it, so it will run 1 minute, but we see that everything is working right. The only thing that we didn't do yet is to handle the unfinished stuff, but we will use it in the next video to handle our modal. The modal we want to show. But we already will create this small function, and for now we will just make a console log saying timer is finished. So now we can see 3, 2, 1, 0, timer is finished. We will handle that in the next video, the fact to show the modal here, but we are still needed to do some stuff. Our hook is okay, so we will commit it. We will add package package files and also src core hooks. Okay. We will not save the changes on the constant. You know, let me check. Yeah, we will just restore it to its previous values. And now we have a last thing to handle before finishing this video. Here we need to understand how the React components are used by React. We know that a React component is just a function. And this function here will be run every time it needs to keep the content updated on the DOM. So that part is the rendering part, but the whole function will be run. By using the hooks, use state, use timer and stuff, we know that those variables will change only when needed. So the whole function will be called only when needed. But every time we run this function, we are declaring 4 small functions. And these small functions don't really need to be declared every time. They can be stable because like handle reset, that can always be the same function. It will just say, okay, reset to session durations. Same thing with set running, and that's why we are going to change it by not using external running value, but just using val opposite val. That's the stuff. So, but this function can be stable. This one too. All these functions can be stable and don't need to be redeclared every time we run the component. For that, React came with a very useful hook, which is called use callback. From React. And use callback just serves to that, to declare some callbacks and make them stable during the lifetime of a component. Just ensure it to redeclare it only when parts of it changes. So here we are going to use that here. So we have the handle minus is a function, and we will just say use callback. And use callback works in the same way as use effect. We give them the function that will be returned and an array of dependencies. Here we have only one dependency, is the set seconds. That's the only stuff that are external to the callback that is used in it, and it's set seconds. Technically, set second is defined only once when use timer is declared. So we know that handle minus will be stable when it's declared. So use callback for here, and we will do the same for every function here. Here it's the same, is set seconds. We don't need to use session duration as a dependency because it came from outside the component, so it will stay stable. If we knew that it could change, we could add it, but it's not the case here. Here it will be set running. And finally, So now we know that those 4 callbacks will not change every time, will not need to change every time. And that's all for now. It will not change the behavior, so now we know that it will run for 25 minutes and at the end just call the unfinished callback. So that's the stuff for now. We will close this video and we will finish in the next by creating our modal, implement it and display it, and then we will publish the code on Netlify. See you in the next video.